I think we can begin. Good afternoon, and welcome to this webinar hosted by the Physicists Coalition for Nuclear Threat Reduction. I'm Steve Fetter, a professor at the University of Maryland and a coalition team member. The goal of the coalition is to increase awareness of nuclear threats and advocate for actions to reduce those threats. Last year, team members gave colloquia at more than 50 university physics departments and laboratories. If you're interested in hosting a talk at your institution in the coming academic year, please contact Charlotte Selton at the email address she will post in the chat. The coalition is funded by the American Physical Society and Carnegie Corporation and works closely with the APS Office of Government Affairs on advocacy issues. Today's webinar is on the effects of nuclear weapons and nuclear war. And we have three outstanding speakers to discuss different aspects of these effects. I'll briefly introduce all three now in the order they will speak. Each speaker will have a total of 30 minutes for presentation and Q&A. Please enter your questions using the Q&A feature during the presentation, not the chat feature, the Q&A, and I will moderate the Q&A and keep us on schedule. Our first speaker is Dr. Matthew McKinzie, Senior Director for Planning and Operations and Nuclear Director at the Natural Resources Defense Council. Matt is also a visiting researcher at the Princeton Program for Science and Global Security and an associate editor of Science and Global Security. He will speak about the direct effects of nuclear weapons. Next will be Dr. Alan Robock, Distinguished Professor of Climate Science in the Department of Environmental Sciences at Rutgers University. Alan is a fellow of the American Geophysical Union, the American Meteorological Society, and the American Association for the Advancement of Science, serves as associate editor of Reviews of Geophysics, and was a lead author of the most recent assessment report of the Intergovernmental Panel on Climate Change. He will speak about the climatic effects of nuclear war. Our final speaker is Dr. Lynn Eden, Senior Research Scholar at Stanford University's Center for International Security and Cooperation. A sociologist, Dr. Eden has written on US politics, nuclear arms control, and US foreign and military policy. Her book, Whole World on Fire, Organizations, Knowledge, and Nuclear Weapons Devastation, won the American Sociological Association's Merton Award for the best book in science and technology studies. Lynn will speak about how US war planners understand nuclear weapon effects. So without further delay, let's begin with Dr. McKinzie.
All right, thank you very much. I'm very honored to be here and to take part in this discussion, in these presentations. Nuclear weapons, nuclear war, unfortunately, it's still a very pressing and existential issue for us, and still so much work to do as scientists, as advocates on these issues. So let me start with some opening thoughts, a couple of opening thoughts. Knowledge of nuclear weapons effects comes from a history of explosive testing in many different environments, laboratory studies, theoretical calculations, and computer simulations. A total of 2,056 tests have been conducted by 7 countries between 1945 and 2017, in addition to the atomic bombings of Hiroshima and Nagasaki. Direct nuclear weapons effects are, I'd say, like the tip of the iceberg. Calculations do have a margin of error. We certainly know enough about the effects of nuclear weapons to understand their danger and the direct effects that I'll be talking about today, but there are so many circumstances around specific nuclear attacks or nuclear war, and weapons of different design may have the same explosive energy yield, but the effects could be markedly different. Nuclear weapons effects touch on many different areas. Foremost in my mind are humanitarian impacts of nuclear weapons, also nuclear targeting, deterrence, and warfighting, the design of nuclear weapons, the issues around terrorist use of nuclear weapons, civil defense, planetary defense, and some basic physics and engineering, including a huge overlap with inertial confinement fusion. I included that quote at the bottom of the slide to give you a sense of the scale of work that has taken place over the years on nuclear weapons effects. just to set the stage. All right, so starting quite basically, an explosion is defined as a rapid release of a large amount of energy within a limited space. Materials at very high temperatures and pressures produce a rapidly expanding shock wave in the surrounding medium. There are several main differences between a nuclear explosion and a chemical explosion. First, a nuclear explosion can be thousands or even millions of times more powerful than the largest chemical explosions. This difference is essentially the difference between the forces that make up chemical bonds and those that make up the atomic nuclei. Second, a smaller amount of material in the weapon is converted to this hot compressed gas in a nuclear explosion. For example, 1 pound of uranium or plutonium completely fissioned releases as much explosive energy as about 8,000 tons of TNT. The complete fusion of 1 pound of deuterium is equivalent to about 26,000 tons of TNT, or 26 kilotons. Third, a much higher temperature is reached in a nuclear explosion, tens of millions of degrees, compared with tens of thousands of degrees in a chemical explosion. So as a consequence, a larger fraction of the energy in a nuclear explosion is emitted in the form of light and heat, both of which this fact is germane to Alan and Lynn's presentations as well. Fourth, a nuclear explosion is accompanied by a burst of initial radiation, gamma rays, and neutrons. And fifth, and finally, a radioactive debris produced in the explosion results in residual radiation or fallout. So in terms of the energy partition, about 85% of the energy in a nuclear explosion is released as air blast or shock in combination with thermal radiation and heat. Of the 15% or so of nuclear explosive energy in the form of radiation, 5% is that initial radiation and 10% is residual radiation that's emitted over a longer period of time. If a thermonuclear weapon has, say, half the yield from fusion and half the yield from fission, then that would cut down or reduce by half, roughly, the amount of nuclear explosive energy in the form of residual radiation. Altogether, blast and shock, thermal radiation and heat, and the initial radiation are called the prompt effects of a nuclear explosion, occurring over the course of about the first minute after detonation. So on this slide, what I've highlighted for you are 3 effects that have to do with the cratering, blast overpressure, and blast dynamic pressure that are central to military planning. However, the other effects of nuclear weapons, thermal, initial radiation, local and global fallout, are very germane to the humanitarian impacts of nuclear weapons and the global effects of nuclear war. A few words about the shock wave, the blast. There are sort of 2 aspects to this. One is a crushing shock wave referred to as overpressure that decreases in intensity with increasing distance from the ground zero. And secondly, strong winds are associated with this blast wave. For example, for a 1 megaton explosion, the wind speeds are several hundred miles per hour near ground zero and still 70 miles per hour about 6 miles from ground zero. This is referred to as dynamic pressure. Of these blast effects, overpressure and dynamic pressure produce direct damage to people, structures, vehicles, and equipment. The blast wave from a nuclear explosion will last longer than that from a chemical explosion and really surround and destroy whole buildings. Most of the military conception of the use of nuclear weapons in war, as I said, has to do with those effects. Quick intro to thermal effects of a nuclear weapon. There really are 2 pulses of thermal radiation from a nuclear weapon. The first pulse is very short, maybe 1/10 of a second or less, and it's in the UV spectrum and accounts for only 1% of the thermal energy of the nuclear weapon. The longer pulse of thermal radiation is the one that causes burns and fire effects very far from ground zero and lasts quite long, 10 seconds for a 1 megaton air burst. Initial radiation, as I said, is the radiation emitted in the first minute from the fireball, neutrons and gamma rays. And the initial radiation is, I'd say, one of the effects that's most sensitive to the nuclear weapon design itself. Finally, residual radiation and I'll go on to the next slide, and fallout. One of the aspects of nuclear weapons effects that struck me when I was first studying this was the fact that there's a threshold for whether local fallout is produced or whether the radioactive debris is lofted into the upper atmosphere and circulates basically within the hemisphere in which the explosion occurred. And that threshold is when the fireball comes into contact with the surface of the Earth, scooping up material, mixing that with the very fine radioactive debris, and then falling out in the vicinity. So on the graph at left, I've marked where the Hiroshima yield and height of burst is, approximately 500-meter height of burst and a yield of 20 kilotons. And so you can see that's in the no local fallout zone. Initial radiation was produced at Hiroshima and at Nagasaki, of course, but there was no local fallout. But it's the local fallout effect that can be the most widespread. The figure at right is from a classic book on nuclear weapons effects. It's fully available online as a PDF, Gladstone and Dolan from 1977. And there they've shown very idealistic fallout contours from a 2 megaton explosion. And the thing to notice there is the time evolution, that it takes hours for the fallout to progress from the ground zero, which is one of the characteristics of civil defense. Given some warning, people can take shelter. One quick note on the EMP effect. This is essentially a separation of charges, asymmetric separation of charge in the nuclear explosion that can be because of asymmetries in the nuclear weapon itself, or the vertical asymmetry in the atmosphere. A high altitude electromagnetic pulse can actually affect quite a large area, even across the North American landmass. And I have colleagues at NRDC who are affiliated with EPRI, Electric Power Research Institute, and they were knocking on my door in 2016 because EPRI had commissioned this study on the EMP and over concerns about the effect of a high altitude EMP on the North American electric grid. And it was a very, very interesting report. Unfortunately, it's behind a pretty steep paywall, but it shows how current this is. EMP effects were only begun to be studied at the end of above ground testing in the United States in 1962. So a lot of it's theoretical and computational studies. All right, when you combine these effects, then you begin to understand how the blast, thermal, and initial radiation together can contribute to casualties. This is a graph that I made trying to understand the casualties from the Hiroshima attack. And I've quoted here again from this Los Alamos presentation, and it's something else that struck me, that most combat weapon effects data is still traced directly to those detonations above Hiroshima and Nagasaki. So you see in this bar graph, the percent killed, of course, peaked at the ground zero, percent slightly injured, peaks further out. I'm sorry, percent severely and slightly injured peak further out because of on the closer to ground zero, those people are at risk of dying, and further from ground zero, the effects are tapering off with distance. So I'll put this all together into a canonical example for you all. The OTA, Office of Technology Assessment study during the Cold War looked at nuclear detonations they compared two cities, Soviet Union and the United States, Leningrad and Detroit, as examples illustrating these nuclear weapon effects on a specific target. I participated in the Vienna Conference on the Humanitarian Impact of Nuclear Weapons in 2014. This was one of several meetings leading up to the Treaty on the Prohibition of Nuclear Weapons, or the ban treaty, that I believe Alan will discuss. And my charge there was to look at a particular military target and put on the glasses of a military targeter and understand how the weapon would be assigned to the target and what the effects were. And so here, the military objective of destroying a hardened underground target where you want to increase the overpressure, that's the scale on the right, what you have on the left is you're increasing the amount of radioactivity in local fallout. So these are limiting civilian casualties from fallout, limiting the extent of contamination is incompatible with that military mission. This was the target that was asked of me. It was it's Aviano Air Base in northern Italy, where the U.S. has tactical nuclear weapons deployed. I'll say during that meeting, an Italian ambassador had words with me about this, but this was the charge I was given. First, zooming right into the satellite image of the database, this is the extent of the cratering effect. This would be the objective of the military attack, to shock and destroy the target underground with this cratering effect of the weapon. Zooming out a bit, you can see the whole airbase, and I'll overlay the blast effects. The units are pounds per square inch of overpressure, crushing pressure, and 8 to 5 psi is still quite a dangerous zone in terms of overpressure, and you can see how it's extending well beyond the borders of the base. Here's the initial radiation, very intense initial radiation that encompasses the base and extends out, fairly comparable to that blast pressure. For this example, which is a 200 kiloton weapon, I hope I mentioned that, and a ground burst. Stepping out a bit to a greater distance, that's the initial radiation effects. Here are the thermal effects. Within about 10 calories per square centimeter, we would expect many fires probably to coalesce in firestorms, subject in Alan's talk, but burn and isolated fire risk extending further out beyond that inner zone as well. And here's the fallout calculation. HPAC is that I used to perform the calculation is the Department of Defense code. I was a beta tester for a while for HPAC, reporting any errors I discovered in the code, but using it also for my own research. So now we've expanded out to excuse me, multi-country view, and you can see the fallout cloud beginning to develop 4 hours after detonation, 8 hours, and 24 hours. HPAC has within it the ability to understand how terrain and topography could affect the fallout pattern. So one thing that was of interest for this conference was basically, would the Alps protect Vienna from this fallout? The answer was no. You'll see this is a very idealized, almost elliptical set of fallout contamination contours. My colleagues and I at the meeting wanted to understand what a better fidelity, better physics calculation might be. And so I constructed this crude block model of the fallout cloud, where I distributed the radiation in these cuts according to data from radiation effects, how much radiation is in the stem and in the main cloud as a function of altitude, and then plopped it in Google Earth to give a sense of what that cloud would look like to people in the environment. And then my colleagues in Vienna used precipitation data to show the very complex deposition of radioactive fallout from the explosion compared to those idealized contours I showed. So just like with Chernobyl, draw a straight line from ground zero or the site of the accident to where you are. There may be contamination in your locality, but there may be clean spots between you and ground zero. And it just shows what I was saying at the beginning, that these direct effects are still being understood, and just the tip of the iceberg in terms of overall impacts of a nuclear conflict. Now, a few words on military application of nuclear weapons. I pulled a slide from this Los Alamos presentation because I thought it kind of expressed well this concept of how to tune the nuclear weapons effects for the military mission. What do you want to destroy is the subtitle. Do you want to couple the energy tightly to the ground, maximize blast and shock? Excuse me. Or maximize radiation emission from the nuclear explosion. The military planning and operations, and Lynn may mention more about this too, sort of distilled a lot of the nuclear weapons effects into a code called the VNTK system, a 4-character vulnerability number that was researched, studied, and analyzed for specific objects that would be attacked by nuclear weapons. And this code distills is mostly blast effects. Codes that start with P are overpressure. Codes that start with Q are dynamic pressure. And these codes are actually used by targeters to calculate the probability that a specific target was destroyed as a function of nuclear weapons effects. And I pored over this NATO Target Data Inventory Handbook from the very end of the Cold War, looking at all the different types of targets. I've listed some here in this slide and their damage level and their VNTK number. But a takeaway from this is that the nuclear weapons effects that we're focused on here are the blast effects. The thermal effects were just neglected in terms of these military planning and operations, and this actually drives the warhead numbers that we see in the arsenals today. Here's another example of military nuclear weapons effects research. This was a test from 1955, Operation Wigwam, 500 miles southwest of San Diego. The question of interest was for anti-submarine warfare, what would be the range of target destruction, hull split, and from the detonation point of the nuclear weapon, and what would be a safe range for attackers? So I encourage you to look at this film. I was going to send links afterwards, but it was an interesting experiment that was put together where they had these surrogate submarines moored at different distances from the ground zero. And if you see the map at lower left, some 18 minutes after the 30 kiloton detonation, 2,000 feet under sea, a ship was badly shaken by a severe earthquake and radioed that it would assist San Francisco with the resulting catastrophic earthquake. And another ship, a military ship transiting the radioactive region, had a huge dose from fallout on the deck of the ship, 400 roentgens per hour. Another example of military applications of nuclear weapons effects. This is from a blog that Hans Christensen from Federation of American Scientists and I did on the B61 Mod 12, a new iteration of nuclear weapons that are earth penetrating. And the idea there is to penetrate at least 3 meters in the earth to more efficiently couple the shock wave and so destroy deeply buried targets. Very much nuclear weapons effects at the forefront of what's going on in the US arsenal today. I've also looked at larger scale nuclear exchanges. This was the first major report I did with NRDC on these issues. We looked at the military effects of striking several thousand using about 1,300 nuclear weapons against military targets. And the question is, even a nuclear strike against completely military targets would have what would be the civilian loss of life? And we found that it was still significant and dominated by this fallout pattern. How am I doing on time, Steve?
We have just 10 minutes left for Q&A.
Okay. What did I just skip to the? Could I just skip to the last 2 slides?
Yep.
Okay, good. Finally, very complex topic: societal impacts. If you haven't looked at these 2 films, they're both available on YouTube. The Day After from 1983 and Threads from 1984. And Threads especially was well researched from the topic of nuclear weapons effects. And also The Day After had this fascinating panel led by Ted Koppel that included Carl Sagan, Brent Scrowcroft, and after watching the film The Day After, Ted Koppel made a reference to Dickens' The Christmas Carol and said, "You probably need it by now, some good news. If you can, take a good look out the window. It's all still there. We have a chance yet to address this address this danger of nuclear war. The vision we've just seen, the vision of catastrophe, is as it will be or just may be. Finally, if you want to explore computationally explore nuclear weapons effects, I just wanted to point out these 4 resources that I think are all interesting and worth checking out. One is the hotspot code for individual nuclear explosions. Another you're probably familiar with is Nuke Map by Alex Wellerstein. There is a GitHub repo, a really awesome resource with a Python library for modeling nuclear weapons effects, both Soviet and US weapons effects formula. And finally, there's a new tool on the block, a nuclear war simulator by Ivan Stepanov. It's on Steam, which is a platform mostly associated with gaming, but I know my colleagues at Princeton are working on this. All right, sorry if I've taken over my time. Thank you.
Yeah, thank you, Matt. So we're now open for questions. I don't see, though, any questions entered in the Q&A, but you can, if you have a question, if you could enter that now. Maybe your presentation was so sobering that our attendees are still absorbing it.
Well, I just while we wait for possibly wait for a question, I'll just say that I'm also struck by how the effects of nuclear weapons are still an ongoing research topic. You see publications in physics journals.
So we do have a couple of questions.
Oh, from Eva. Hi, Eva. What is your opinion on the accuracy of the GitHub simulator as opposed to the other ones, which I am more familiar with? Well, the GitHub, the advantage of that is that it's a Python API, and so you can use objects, methods, and functions in your own Python code if that's how you do your research. But the formula are consistent with on the US side in the repo are consistent with Gladstone and Dolan and a more extended version of Gladstone and Dolan called EM1. So I highly recommend it. When will the Steam simulation be available? It was hosted at itch.io, which is a platform for indie Unity game developers. And I know Ivan Stepanov is transitioning to Steam. And I was looking at it today and seeing that it wasn't quite ready to download from Steam yet, but I downloaded it earlier from itch.io and have worked with it, and it's really impressive what he's done in code. Peter Somsich, can you compare roughly the impacts of different types of? I'm afraid your question seems cut off to me.
Can you compare roughly the impacts of different types of nuclear bombs, uranium versus plutonium?
Uranium versus plutonium. My understanding, and I haven't worked with classified information ever on nuclear weapons, but my understanding is that contemporary nuclear weapons are a mixture of plutonium and uranium in the core, in the pit. But regardless, there are design advantages to plutonium as opposed to uranium, and those design advantages may very well translate to nuclear weapons effects, because, as I said, some of the effects are driven by the size of the material that is raised to very, very high temperatures. And so that's as much as I can speculate on the spot, but I'm going to take your question away.
And why don't, just to make it simpler for you, I'll field the questions. Is there a Soviet or Russian equivalent of Gladstone and Dolan available anywhere that you know?
Well, that's an interesting question. I haven't seen quite the Soviet-Russian equivalent of Gladstone and Dolan. There is a Russian literature on the effects of nuclear weapons. I don't know if any particular book rose to the same stature of Gladstone and Dolan. One almost unrelated footnote: the day after actually aired in the Soviet Union in 1987.
Ben Tannenbaum just wanted to follow up on Steam. Is that a single player or multiplayer simulation?
I do believe it's a single player simulation, but I think it's a dynamic project worth following. So I don't know what he may have planned.
Is there a means to calculate the sorts of geological after effects of a blast? For example, what sorts of extra damage would be done to targets lying near fault lines, et cetera? I think this is referring to triggering seismic activity, but I'm not sure.
Yeah, that's a very interesting question. It jogs my mind to think about the what were called peaceful nuclear explosions, or engineering attempts to use nuclear weapons for engineering purposes. If you can believe it, fracking, for example, stimulating oil and gas reservoirs, as well as digging harbors and so forth. And I know that I do recall that part of the issue around stimulating oil and gas production, including the radioactivity, was also stimulating earthquakes.
And Michael Alexander asks, have you or your colleagues compared computations based on unclassified sources with those from classified sources? I think we should make clear that your work is exclusively unclassified.
Correct.
Perhaps there has been declassified material that you're aware of?
I think there are some nuclear weapons effects that are considered more sensitive than others. And as I mentioned, initial radiation is an example of that, because it depends much more closely on the specifics of the design. And so I would expect there's probably quite a bit of literature on initial radiation effects that's classified. A lot of the EMP research is probably partially classified. When I first started working on fallout effects, I was glad that fallout data was largely unclassified, so I could run these codes and compare it with measurements that were taken in experiments. So,
okay, and I am afraid that is all the time.
Okay, thank you.
Q&A, but thank you very much. And we will now go to our next speaker, Alan Robock, who will talk about the climate effects of nuclear explosions and nuclear war.
Okay, Matt, if you could stop sharing your, there you go, thank you. Hi, thanks very much. I'd like to talk about the, that's my webpage, which I put a link to. I'd like to talk about the effects on climate and food. So this work is sponsored by the Open Philanthropy Project. This is a picture of some of us old guys who've been working on this for a while. At the last meeting we could attend in person, Rich Turco, Brian Toond, Tom Ackerman, me, and Gira Stenchikov, who did the Russian work. But we're also working with a bunch of younger people too in our project who work on crop modeling and ocean modeling and climate modeling. And we published a number of journal articles about this in journals like PNAS and Science. And so all these papers are on my webpage, which I put in the chat, and feel free to download them. I'll just have time to skim some of them. So here's the story. Here's our beautiful planet. But after a nuclear war, it might look like this, with smoke covering it, blocking out the sun, making it cold and dark at the Earth's surface. And if there's enough smoke, temperatures will be below freezing, even in the summertime. We call that nuclear winter. And of course, that would affect crops and produce global famine. Here's a graph of the history of the total number of deployed nuclear warheads. As you can see, there was this arms race, and then it ended in the 1980s. And so why? Well, Crutzen and Birx pointed out that there would be smoke after a nuclear war, and it might cause climate change. And then a Russian group and an American group both calculated how the climate would change, and they found out temperatures would get below freezing. There would be nuclear winter. And then I did another paper in Nature, and Covey et al. Did, and then the arms race ended. And I assert that this was science talking to power. Why? Well, the Soviet Union ended 5 years later. That wasn't what caused the end of the arms race. It was already over. You can ask the people who actually made the decisions, and also point out that the number of weapons is not zero. The number's been going down, but we still have lots of nuclear weapons deployed. So Ronald Reagan was asked about this, and he said, a great many reputable scientists are telling us such a war could end up in no victory for anyone because it would wipe out Earth as we know it. If you think back to natural calamities, there was in the volcanoes, we saw the weather so change. There was snow in July, and they called it the year in which there was no summer, and the nuclear winter that scientists are talking about. And Gorbachev said, models made by Russian and American scientists showed that a nuclear war would result in nuclear winter. And so these are the people that made the decision. But the problem, so the arms race is over, but the number of weapons is still very large. So why am I even talking about this? This is 40 years later now. Could we still produce a nuclear winter? And now there are 7 more countries with nuclear weapons. What would happen if they had a nuclear war? And the answer is yes, we can still produce a nuclear winter, and it would last for many years. And a smaller war, say between India and Pakistan, would not bring temperatures below freezing, but the direct effects, as Matt was describing, will be horrible, and there would still be global agricultural impacts. So our project is to calculate those. During the first nuclear war in Hiroshima, a 15 kiloton bomb was dropped, which killed 150,000 people. And this is the airplane that did it, the Enola Gay. This is me a long time ago in the Smithsonian. This is a mock-up of the uranium bomb that was dropped called Little Boy. And this is the mushroom cloud caused by the blast. And then several hours later, there was this pyrocumulonimbus. This was caused by the fires that were started, and they pumped smoke and cloud all the way up into the stratosphere. So it's this fire that is started by the bomb, which is what causes the climate effects. And this is a drawing done by one of the survivors. They remember the fire in Hiroshima. There's another one, a streetcar burning, and another one of a department store burning. And this is what Hiroshima looked like afterwards. The buildings went up in smoke. And then this is Fat Man, the bomb that was dropped, the plutonium bomb that was dropped in Nagasaki 3 days later. And this is the mushroom cloud from that. And Nagasaki also had a huge fire. Now, you don't need nuclear weapons to do this. There was an earthquake in San Francisco in 1906, which started a 3-day fire. And Jack London wrote about it. And he said, I watched the vast conflagration from out in the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing in upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. So this firestorm that can pump the smoke up is what would happen after a nuclear war. And this is what San Francisco looked like afterwards. So now there's about 13,000 nuclear weapons in the world. And this is a graph showing the Russian, the US, and the other 7 countries. The red are missiles on land-based ICBMs, the blue are on submarines, the green are carried on aircraft, and the gray, which are sitting on shelves, waiting to be, so they aren't deployed. They weren't in my last graph. Let me blow this up so you can see it. And the US and Russia still have 5,000 or 6,000 weapons. These other countries have China 350, France 290, Britain, Pakistan and India have over 160 now. And so this is a picture taken from the space station. This orange line is a border between 2 countries. This is India, this is Pakistan. And all these lights here are cities, huge cities, which if they burn would produce tremendous amounts of smoke. And so we asked 15 years ago, what would happen if India and Pakistan had a nuclear war? You can imagine a skirmish in Kashmir escalating, and these are both nuclear countries. There have been a lot of fighting between them over time, even recently. And so at the time, each one had only 100 weapons, and we assumed that they were small, 15 kiloton size. And so we asked, what would happen if each of them used half of their arsenal and put them on targets in the other country. And the direct effects would be horrible, as Matt talked about, but it would produce maybe about 5 million tons of smoke injected into the upper atmosphere. This is a climate model simulation of the smoke. This on the right is horizontally where it would go, and on the left is the vertical distribution. This black line is a tropopause. We live down here in the troposphere where there's rain to wash it out, but the smoke would be heated into the stratosphere where there's no weather and blown around the world and lasts for years. And then we calculate what would be the climate effects of this. And this is a graph of global warming, which is also a problem, but here we would have instant climate change. Temperatures plummeting 1.5 degrees Celsius to temperatures colder than ever before recorded in human history, colder than the Little Ice Age. This is for 5 million tons, 5 teragrams of smoke. But the US and Russia have many, many more weapons. So we have 14 tridents, and they have much bigger bombs. And so a trident is as powerful as 1,000 Hiroshimas, not 100 Hiroshimas that I just showed you. And Russia has the same, and that's only half of their arsenal. So there's about 50,000 Hiroshimas worth of explosive power. And so we said, let's calculate what would be the effect of a war between the US and Russia. And this will put either 50 or 150 million tons of smoke, not 5. And the current arsenal can still do this. And so here's a movie of what happened after a war between the US and Russia, much thicker smoke. And the next year, this is the summer, Northern Hemisphere summer, this is the temperature change. And it would indeed be very cold. And so let's take a place in the Ukraine and draw a graph. And so the black is the minimum temperature every day. This is in the control case, and temperature would be warm in the summer, 20 degrees Celsius, below freezing in the winter. But after a nuclear war, temperatures would go below freezing and stay there for a couple of years. So indeed, nuclear winter was correct. We now see it with a modern climate model. And this was 15 years ago, but our recent calculations get the same result. And we also have redone the Pakistan-India case. Now they have a lot more weapons. So we figure in a few years, they could have larger weapons, more weapons, the targets would be a bit bigger, and a war between India and Pakistan in the near future would maybe produce 16 to 36 million tons of smoke, not 5 like we did before. And so here's a graph of the surface temperature from all these different scenarios. The blue is what I showed you before for India, Pakistan, 5 million tons. The green is US and Russia, 150 million tons. And these are the intermediate ones. So say this orange line, India, Pakistan, 37 million tons, temperatures get more than 5 degrees below freezing, below normal. And that's how much cooling you got during the last ice age when there were 20,000 years ago and there are ice sheets covering North America. This would last for several years. So what we really care about is food. How would this affect our food supply? And if you replot the graph of the global warming, this is the 5 teragram, 50, 150 teragrams of smoke. So how would nuclear war affect agriculture? Well, it would be darker, so there'd be less sunlight. It would be colder, so the plants would grow more slowly. The frost-free growing season would be shorter. You would need more time for crops to mature. They might not even reach maturation. You get these cold spells during the growing season, and there'd be less rainfall. And we have crop models that we were able to apply temperature, light, and rainfall to. And there's a lot of other things like toxic chemicals, no seeds, lack of fuel, lack of water supplies, lack of pesticides, enhanced ultraviolet radiation, because ozone would be destroyed. We really haven't even addressed these issues yet. We've only had time to look at these basic things. And so where does food come from? So the global average diet, you typically need about 2,900 kilocalories per person per day. 65% comes from these cereals, 17% from vegetables, 18% from livestock, which includes fish, milk, eggs, and meat. And of the crops, some of it's used for feeding animals rather than for human food. So we tried to calculate how all these cereals change in our crop model models wheat, rice, maize, and soybeans, and we have a model for fish. And those are the ones we've done so far. And this is an example for 5 million tons of smoke. This is how much the average change of corn production would be in different places in the world. In the global average of 13% reduction, some high latitude countries like Russia would have a 50% reduction. And from a lot of different crop models and different climate models, and for 16 teragrams would have a 34% reduction in corn. And we combined all of these with different crops with their calorie content and calculated the amount of food available. And you get for, say, the 37 teragram case, a 40% reduction in food globally averaged for several years, year 1, 2, 3, 4, 5. And then we said, well, what does that mean? So this is a graph of the total amount of calories available for these different simulations, 5 to 150 teragrams. And the yellow is if all the livestock, we keep feeding them. And the red is if we stop feeding livestock and start feeding humans with the feed. And this is the normal amount of calories. If you get below 2,200 calories per day, you can't maintain your body weight, you're losing weight. If you get below 1,600 calories, you can't even stay alive. Your resting energy expenditure is not satisfied. So globally average, even for an India-Pakistan case, it would come close to killing many, many people. And the US and Russia case, certainly. So we can, but that's global average. So let's look at the maps. This is with international trade, the current amount of food. Basically, everybody has food. If there was no international trade, you can imagine people stopping exporting. And then a lot of countries which are big exporters, like Saudi Arabia and other countries, really depend on trade right now. So we did cases with and without livestock in the second year, with and without trade. And for 27 teragrams, for example, high latitude countries would be in big trouble between a war, because of a war between India and Pakistan on the other side of the world. And this goes down to 150 teragrams. So you can see for that, everybody would be in trouble. We did a calculation in year 2, just for the 9 countries with nuclear weapons, how would the food availability change, the percent of calories? So say for 27 teragrams, the high latitude countries, China, North Korea, Russia, the US would be in a lot of trouble. And this is with no trade. And so in this case, the US would have a lot of wheat to eat, but at higher levels, it would be terrible. So this is all models. We use analogs to test our theory, including the seasonal cycle, night and day, cities burn, volcanic eruptions, forest fires. I'm just going to give you a couple examples. 3 years ago, there's a big forest fire in Canada, and it pumps smoke into the stratosphere. And we use the same climate models to calculate what would happen. And compared to observations, the smoke was heated by the sun and lofted more than 10 kilometers into the stratosphere and blown around the world. And then a year and a half ago in Australia, there were big forest fires that put 3 times as much smoke, and our model still calculated it correctly, but that was much less smoke than you would get from nuclear war. So that gives us confidence in the models. This is the Tambora volcano that Ronald Reagan mentioned in 1815 that produced the year without a summer on the island of Sumbawa. And a lot of work has been done on this. I'll just give you one quote from Gillen Wood. This is a graph of the temperature in New Haven in the year after the year without a summer. And he said, for 3 years following Tambora's explosion, to be alive almost anywhere in the world meant to be hungry. And that was for a global average temperature change of about 1 degree. So a nuclear war between any nuclear states using much less than 1% of the current arsenal would produce climate change unprecedented in human history. Such a small war could produce global starvation with massive increases in ultraviolet radiation. The current arsenal can still produce nuclear winter, killing most of humanity. So there have been treaties to ban nuclear weapons in different places, in Antarctica, Latin America, outer space, Africa. And the latest that Matt mentioned, the Treaty on Prohibition of Nuclear Weapons, is to ban nuclear weapons everywhere. It came into force earlier this year. If you look at this map, all the blue areas have no nuclear weapons. So there's no nuclear weapons in the Southern Hemisphere. There's 6 countries in Asia that have them, 2 in Europe, 1 in North America. The ones in yellow have treaties with the nuclear countries. And the ones in orange actually have them based there in Turkey, Italy, Germany. Brian Toon and I looked at our results and we said, you know, people used to think it was mutual assured destruction, but actually, you know, but it's actually self-assured destruction. If we attacked another country and they didn't even do anything back, we would all starve to death. So how could you even believe we would use our weapons? We would be acting like a suicide bomber. And the country said, well, no, we're not going to use our weapons. We're going to use them they're for deterrence. They're to deter attacks. But there's many examples of conventional war where nuclear weapons don't deter attacks. The Six-Day War, the Malvinas, the Falkland Islands, Afghanistan, both the Soviet Union and US couldn't win, and they're both nuclear countries, Vietnam. Oh, we're deterring other nuclear countries. Well, there hasn't been a second nuclear war, but there's a lot of other reasons possibly. But if deterrence really is the goal, will it last forever? And there've been many very close calls. For example, the Cuban Missile Crisis was the worst. I took this picture in Havana. This is one of the 36 missiles that the Soviet Union put in Cuba, and there was President Kennedy put an embargo and tried to stop them from coming in, and told Khrushchev, don't tell anybody, but we'll get rid of our missiles in Turkey if you get rid of them. And fortunately, it did not start a nuclear war. But a submarine almost launched a nuclear torpedo on October 27th. The U-2 spy plane was shot down over Cuba, so it came very close. And I had the surreal experience of talking to Fidel Castro about this. He invited me to Cuba twice to talk about a nuclear winter. And he told me, you know, the Russians, a ship arrived every day with supplies, so we couldn't say no when they wanted to put nuclear weapons. But President Kennedy understood this 60 years ago at the General Assembly of the UN. He said, every man, woman, and child lives under a nuclear sword of Damocles hanging by the slenderest of threads, capable of being cut at any moment by accident or miscalculation or by madness. And he gave a speech to the United States about the Cuban Missile Crisis. And the day before, he told a friend, the world really is impossible to manage so long as we have nuclear weapons. It's really a terrible way to have to live in the world. But that was 60 years ago.
Alan, we have 10 minutes left for Q&A.
Okay, I'll be done very soon. Martin Sherwood wrote a book. He said the real lesson of the Cuban Missile Crisis is that nuclear armaments create the perils they are deployed to prevent, but are of little use in resolving them. So the international campaign to abolish nuclear weapons got the Nobel Peace Prize in 2017 for starting this treaty and taking advantage and warning the world about the humanitarian impacts. And Beatrice Finn, when she accepted the Nobel Peace Prize, said the story of nuclear weapons will have an ending, and it's up to us what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destruction is only one impulsive tantrum away. So I'll stop here, and I hope we can learn from this, and that our beautiful planet will look like this for a long time to come. And if you want more information, here's the webpage, and you can also, I also put this in the chat, and I'll be happy to answer questions.
Thank you very much, Alan. So Fred Lamb asks, even if crops can be grown, they cannot feed people unless the food can be distributed to the population. Could you comment on how nuclear war would affect food distribution within the United States and Russia?
Our analysis so far, we use national data. The Food and Agricultural Organization has national data on the amount of food, amount of imports and exports. And we haven't gotten to the point of how much hoarding there would be within a country. But you know that would happen when there was a drought in Russia in 2010. They stopped exporting wheat. But just think of toilet paper last year. That all you have to do is think of toilet paper in the pandemic, and that will tell you how people hoard food. So yes, it would be horrible. If you so the solution, of course, is not to have it happen in the first place. But that we haven't done the analysis of human behavior, which is much more difficult to study than the physics of the atmosphere.
And Peter Somsich asks, can you compare the risks and consequences of climate change from rising greenhouse gas emissions to those from nuclear winter?
this would be instant climate change. And so it would be, and global warming is gradual climate change. And so people might have time to adapt to certain amounts of climate change. And we also, because we know it's happening, maybe we'll be able to leave the fossil fuels in the ground and stop the worst things from happening. But there's no defense against this. Once the smoke's in the atmosphere, it will stay for years.
Michael Alexander asks if firestorms were created during World War II from both conventional and nuclear bombings, were climate effects observed from those firestorms, and would that be a validation?
I wrote a paper about this. You might not know that on March 10th, 1945, the US burned Tokyo and killed more people in 24 hours, burned to death than any other time before or since in the history of our planet. And about every 3 days after that, we firebombed different cities in Japan. And Hiroshima and Nagasaki were just the 67th and 68th cities that we burned. We already had a program of genocidal bombing of civilians that killed about 800,000 people. And I estimated how much smoke came from Japan during all those cities burning, and looked at observations of how temperature changed in the next year and even how much sunlight came through. There were 2 observatories, one in California, one in Chile. And it turns out, theory tells you, based on crude estimates, we would expect 1 or 2 tenths of a degree cooling, but the data were so noisy and the natural variability is so large that you couldn't really detect a signal with the data that we had.
Ava Lisowski asks, you mentioned something about the effects of smoke would cause a lack of pesticides. I remember you said your team had modeled this in detail, but what sort of conceptual explanation of why there would be a lack of pesticides?
Well, we assume that the global infrastructure for industrial infrastructure would be destroyed. And so you wouldn't be able, as Fred asked about food, you also wouldn't be able to distribute the supplies that farmers need. So there wouldn't be pesticides, there wouldn't be fuel for farmers. If everybody in the US knew how to farm and everybody went out in the fields, we couldn't grow nearly as much food as we can with our current mechanized agriculture, where fewer than 1% of the people work on it. So some pests are known to survive pretty well high levels of radioactivity. So that was I think agriculture would come to a halt, and because of it, the infrastructure would be damaged so badly.
And Julia Desmarines asked if the calorie requirements that you used for the modeling, were those based on an average for men and women?
Yeah, they were an average for men and women, and based on culture and based on how big you are and how old you are. And so we just sort of took the global averages, but some people would need a lot more and some people would need a lot less. So we would just sort of average that as our first rough cut. We're going to try and do it in more detail, but that's about where we are right now in our research.
Kevin Leva asks, are the tons of smoke that lead to climate effects solely from the firestorms caused by a nuclear war?
Yes. We calculate, we assume there would be air blasts over cities and industrial areas. And the military claims we only target military targets, but there just happen to be military targets built into all the cities. I mean, Fidel Castro was telling me that, in preparation for the invasion of Cuba, they distributed their airplanes to all the airfields in the country, not in one place. And so, National Airport's right in the middle of Washington, D.C. There's also a funny 5-sided building there that certainly would be targeted. And so there are all kinds of command and control centers in cities. And so we assume that cities and industrial areas would be burned.
That is all the questions that I have have been entered so far for you, Alan. But I guess I could ask, could you just describe how the estimates of the soot production are made?
Yeah, we did an estimate of how much material there is in each place based on the population. And there were some detailed surveys in the 1980s, like for Nashville. They took every building in Nashville, every school, office, home, factory, and calculate how much material there was in it, how much wood, how much paper, how much furniture, and so forth, how much fuel there was from oil, like asphalt will burn and gas stations will burn. And we calculate how much smoke there would be, and then what fraction would actually make it to the stratosphere, what fraction would turn into soot particles, and what fraction would not be washed out by rain. So that's what we've done so far. We're doing surveys now of cities around the country. Zillow, turns out, has a database of every building in the United States. We're working with that. And we're also modeling firestorms of burning cities. There are detailed models of forest fires with three-dimensional hydrodynamical code, but we're applying that to do firestorms in cities and how much smoke would be pumped up from firestorms. And we're in the middle of doing that modeling. We haven't completed that right now. But there are preliminary calculations where if you start a city on fire, it would definitely pump smoke up in the stratosphere. And fires in forest fires, the terrible ones in Australia and in British Columbia, certainly put smoke up in the stratosphere, and we can easily see it with satellites. And the smoke from the Australian fires is still up there over a year later.
Cheryl Spencer asked, who do you send your articles to in the US government or US military?
We're trying to get them to pay attention. And maybe you could tell me, Steve, what happened in the Obama administration with this information. But because Steve worked for the Office of Science then, but we were able, through the Physicists Coalition, especially Frank von Hippel and a friendly congressman, to put a requirement in the current National Defense Authorization Act that requires that the National Academy of Sciences do a study of the climate and environmental effects of nuclear war, and that the Defense Department work with them. That's happening right now. We haven't heard from them, but I know the person in charge at the National Academy, and she's in touch with us. And so within a year or so, there will be a National Academy report about this. In the 1980s, there was a National Academy report about nuclear winter that was very influential because it was really, people took it seriously because it was done by the National Academy of Sciences. So that's being done again. We try to talk to people in the military, and so we don't know what they do in secret, but they really haven't. We publish all our information and put it on the web and write journal articles. Brian and I are writing a book now, and so we're trying to get the word out. And that's part of the reason the Physicists Coalition now. I'm a member along with Steve, and we have 13 members, and we have over 500 members now in the coalitions. We're trying to get the information out.
Okay, well, that is all the time we have for this session. I would just like to respond quickly to one question that Morton Brussel asked about what APS is doing on this set of issues, and that really is a question for APS and particularly for government affairs. I can say that the coalition does propose certain advocacy issues as candidates for APS to consider for its efforts in lobbying Congress. So you could talk to your APS representatives and the panel on public affairs about that. But thank you, Alan. Our next and last, but certainly not our least speaker, is Lynn Eden. Dr. Eden.
I cannot see anything on the screen. Is that what I should be seeing? All right, doesn't matter.
I can see you, Lynn.
Oh, okay, and that's fine.
Everyone can see you.
All right, that's fine. Okay. I'm going to shift the discussion a little bit. I want to ask, how do good people plan the end of the world? That is, plan large-scale strategic nuclear war. And I mean this literally. How do morally good, dedicated military officers develop highly specific nuclear war planning options that, if implemented, would cause calamity on an incomprehensibly vast scale, as we have just seen? In terms of immediate deaths, it would kill tens to, my guess is, and you can ask our other two speakers, that it would kill tens to hundreds of millions of people, and obviously global environmental catastrophe. So how are those involved in detailed nuclear war planning able, to some degree, to avoid thinking and having some pretty strong feelings about the consequences of nuclear war? at least to get on with their work of planning it. Matt referred to some of these planners. He talked about, well, he referred to planning done by the military. He talked about computational efforts. He talked about military targeteers, objective of an attack, and objectives being what is targeted, and never mind the collateral effects. So these are the people I'm talking about. So let me give you an example. This is someone who was involved in targeting. And this is when this official first started. And here's the quote. "It was an emotional burden to read the war plans. You begin to lose sight that you're talking about the end of civilization. You look at this and think you might actually have to employ one of these plans someday. And it's just mind-boggling. I thought, my God, it isn't just an abstraction, it's real. This is what we, the US government, intends to do in X, Y, or Z situation." So that was incredibly overwhelming. And it was actually hard to work during the first couple of weeks. Hard to take any of them seriously because I wanted to shake them and say, are you fucking kidding me? Are you out of your mind? How can you possibly consider an attack option that looks like that? I think that when you work long enough on targeting, at a certain point, you have to stop thinking about what executing one of those options really means. Because I don't know how you could live with yourself if you didn't cut off. So my question is a form of the quote. It's moral, it's social, psychological, and it's organizational. What has enabled US military officers to make highly detailed plans to fight and prevail, in Ronald Reagan's words, a nuclear war that cannot be won and must never be fought? Of course, developing a plan, including options, does not mean that US officials want or intend to go to war. We expect such plans to be developed for conventional armed conflict and war. Similarly, such plans are routinely developed for nuclear war. But how do people in an organization avoid thinking about the results of the very thing they are planning? So for the next few minutes, and I plan to run short here, I'll do two things. First, I'll very briefly sketch out how US nuclear war planning is organized. And then I'll look at 4 or 5 organizational processes that enable war planners to carry out their tasks. Underlying most of these explanations is that as war planners do their jobs, they generally don't focus on the human and civilizational responses. That is, as I just quoted, they stop thinking about what executing one of these options really means. How they do this is my focus. Does this make war planners different from others who work in bureaucracies? I think in general, I will argue strongly that the answer is no. There's nothing that's at the psychological level that could explain this ability. So first, let me talk about the tiers of nuclear war planning. I've focused today on the most detailed tier, the place where the actual detailed nuclear war plans are updated and revised. For most of the Cold War, these planners worked in a multi-service or joint planning group called the Joint Strategic Target Planning Staff, JSTPS. The group was joint, but it worked under the legendary military command, the Air Force's Strategic Air Command, located at Offutt Air Force Base, just outside Omaha, Nebraska. Think of Dr. Strangelove, General Curtis LeMay. That's where this is, you could say, their home. SAC personnel dominated nuclear war planning. They were dual-hatted, that is, SAC officers who also worked at JSTPS. There were officers from other services, particularly the Navy, but also from the Army, Marines, and representatives from NATO. After the Cold War ended, in 1992, SAC became the Joint Command STRATCOM. And the name of the planning group changed, but the functions did not. So JSTPS is now the more generic J5. J for joint, 5 for planning, a standard designation across all US military services. So here's what happens. The planners use and must follow increasingly detailed guidance. They're not making this up. First, there's broad presidential guidance. This is written in the White House with some negotiation below. There is a back and forth. It's very broad. Then there's more detailed Department of Defense directives, and yet more detailed instructions from the Joint Chiefs of Staff planners on how to build planning options. In addition, planners developed their own translation of instructions known as the Blue Book, for many years completely unknown at higher levels to even exist. As the Cold War ended, SAC was reconfigured as a joint command, now known as STRATCOM. So from the mid-50s, nuclear war planners have worked in the same set of offices in an underground annex to SAC STRATCOM headquarters. The annex is located 3 stories below ground, at least in part under the front lawn of what for decades was SAC STRATCOM headquarters. I'm fudging a little here because there's a brand new headquarters for STRATCOM, and it's basically across the road. And so I don't know if this basement, or what was called the molehill, is still there in part, or if they moved it over. I just don't know. Most of the planners are active military officers. Over time, some planners stayed on or came back as retired military working for or as contractors. These former military personnel may have considerable expertise, and they also provide important continuity. So what enables, at a social psychological level, at an organizational level, what enables planners to plan the end of the world? I will give 4 or 5 examples, reasons. First, planners understood and continue to understand that the purpose of nuclear weapons and nuclear war plans is, above all, to deter an opponent, an enemy, from taking actions antithetical to America's and America's allies' interests. How do plans, capabilities, and willingness to act, if necessary, deter? Well, it's quite obvious. They demonstrate what would await an enemy should it attack, what it must not. However, should deterrence fail and US nuclear weapons were deemed both legal and necessary by military lawyers, under presidential order, the war plans could be implemented to get the best political military results possible, whether through options based on first use, retaliation, massive attack, or limited, what is called tailored use. For most of the Cold War, Air Force leaders generally thought nuclear war could be meaningfully won. That's Air Force leaders. Military leaders do not say that today, though for some, depending on the circumstances, choosing some options over others could or even would make a significant difference, a better outcome for the US and its allies. In sum, for planners, the people at the bottom doing the targeting, the fundamental use of nuclear weapons is not to employ them, but to dissuade anyone else from using them or from taking overly aggressive action. Second, nuclear war planners do not intend to kill civilians. So the first is, we have these plans we can implement because the threat of using them won't deter, as Matt actually said. Second, nuclear war planners don't intend to kill civilians or destroy what they call civilian objects, that is, universities, art museums, housing, hospitals, sports stadiums, and so on. Planners do have options, measures, and procedures to withhold attacks against major urban areas. But there are also many crucial targets in cities that under most circumstances cannot be avoided if you're engaged in something fairly large scale. Planners do know that many civilians would be killed in a nuclear war, but, and this is significant for them, they would be killed only when it is unavoidable to kill them. Civilians per se are not an objective of war planning, or as planners would say, civilians are not objective to the plan. So the second enabling process, collective enabling process for war planners, is that their intentions are good. Third, military career paths can make dissent extremely costly. The criteria for career success in the military is different from those in the civilian world. In the civilian world, one can move, you can move up the ladder, you can switch jobs, job sectors, employers, possibly many times. Or if one is self-employed, one may have flexibility in what one does, where, and how. By contrast, a full career in the military requires at least 20 years of service. That is to get your full retirement benefits. Every service member takes an oath of office to defend the US Constitution, to act honorably, and to obey legal orders, including the laws of war. Scott Sagan and Alan Weiner have recently written, and recently actually in the Washington Post, on how legality is incorporated into nuclear war planning. Presumably, while the president is making a civilizational decision, the lawyers are either there or with the targeteer saying what they can and cannot do. This sounds a little bit suspicious to me, as in a fantasy, but this whole thing is so hard to understand as actually being real I will say that certainly they intend, that is the lawyers and officers, in an abstract way, to obey the laws of war. Service members are obligated not to act illegally. The issue is who decides, and what will questioning legality do to a military career. The continuity in career commitment requires that for those who are ambitious, as many are, excellence must be reflected in performance reviews called ERs, or efficiency reports. In addition to what I've just said, sheer, hard, concentrated work is required, including serious study in the evenings, paying attention to detail, repeated practice of what must be mastered, and successful performance in various kinds of tests. This is true throughout the military. One should be highly capable as a team member and leader. One has an obligation to report poor compliance and bad conduct. This is obviously somewhat idealized, but this is, I would say, the higher up you go, the closer to this you really do, there'll be a list, you know, do you pass this, do you pass this, do you pass this? At the same time, in some circumstances, it is prudent not to express thoughts that go against widely accepted political or other views, to raise hard questions that really cannot be answered. In all, career officers face more difficult choices when assigned to do something one might rather not, such as planning nuclear war. Officers have pledged loyalty. In most circumstances, they cannot modify the work they do. An exit is a radical career-changing option. Also, war planners are on this rotation, I would say 2 to 4 years. I hope our other speakers and Steve will correct me on anything I'm saying. Okay, fourth, to succeed at nuclear war planning, officers must focus on highly prescribed analytic tasks. Mathematical abstraction, specifically the mathematical process of optimization, provides the planning framework. Within this framework, linear programming techniques are used to achieve a goal optimally. The goal is termed the objective function. I'm talking to physicists. You all know this. And it's expressed as a maximum or minimum quantity subject to constraints. For example, for an investor, the objective could be to maximize expected return on a financial portfolio, or to minimize tax payment or given financial investment subject to constraints of law and regulation. For a package delivery company like Amazon, the objective function could be to minimize the time of arrival of packages at specified locations, subject to constraints of handling, so that packages do not arrive with battered contents. For nuclear targeting, the objective function is to maximize the achievement of specific damage goals to classes or categories of targets. And the classes and categories are measured. They have these VNTK numbers, just as Matt talked about. So the goals themselves are termed damage expectancy. Achieving this requires most efficiently allocating several types of nuclear warheads carried on ICBMs, sea-launched ballistic missiles, and aircraft. Planners assign types of weapons to types of targets. They allocate it. They then assign specific warheads to specific targets, and they time their launches for particular times of arrival, height of burst, in order to achieve, with specified probabilities, designated damage goals. For example, for a specific class of massive industrial structures, the damage expectancy could be severe damage with 90% probability. And severe damage means it's leveled or burned up, though they're not using fire. That would, in some definitions, be severe damage. So basically, has it collapsed? And has it collapsed in such a way that it really can't be rebuilt? Built using, yes.
Oh, we have 10 minutes left.
Okay.
Questions
All
and
right.
answers.
Okay. Using Monte Carlo methods, targeteers simulate planned courses of action to assess the degree to which they've succeeded in achieving their goals. So they might find, once they test it, that only 70 targets out of an expected 80 targets would be severely damaged. And this would require, for this class of weapons, using different warheads, more warheads, moving the locations, etc. And again, it's a very detailed, focused process. So this indicates, if we're looking at it from a distance, what is left out of these abstractions and what might move someone to say, I really just can't do this. What's left out are images of people, a sense of daily and cultural life, places as they would be experienced by sight, sound, and smell, except for withholds against certain urban targets under specified conditions. There is no hint in the math that's involved in the procedures of the violence being planned, nor would we expect there to be. Civilian deaths are not included in the categories because, as noted, civilians are not objective to the plan. In nuclear targeting procedures, an officer's required focus, it is as if people and civilization do not exist. They certainly do not count. I'm done.
Thank you very much, Lynn. We have several questions. Jerry Peterson asks, in a world of perfect discipline, there is one person who decides the response. I assume this refers to the decision to use nuclear weapons. How do we influence the ethics of that person?
Well, of course, we vote for that person, and we see who wins, and we accept who wins in a democratic process. that we still live in. I think that public mobilization is very powerful, and that also has an impact on Congress. I think what this coalition is doing is the kind of thing that could filter up, create a climate, a political climate in which a president who's been elected has some brains and sense of ethics.
Douglas Shaw asks, what convinces targeteers that the damage they estimate will produce deterrence?
It's pretty much a given. Maybe in theory, they could say, well, maybe, but they would say it's very robust. We haven't had a nuclear war, and so we're just fine. It's the first thing you would want to do to relieve yourself that you're not doing something that's evil beyond evil.
Peter Somsich asked two related questions. How can we persuade countries who feel threatened by other countries not to acquire nuclear weapons to defend themselves, as they see this as self-defense? And related, how can the Non-Proliferation Treaty provide incentives so that it's more advantageous to forego nuclear weapons?
I'd be interested to hear what others say. There are a number of countries that have thought of doing nuclear weapons, begun an infrastructure, and then stepped back, including Sweden, for example. It's not inevitable that if a country wants to develop nuclear weapons or feels threatened that they will do so. It's enormously expensive. And in terms of diplomacy, unless you can make some claim, I mean, this is a way of making a claim that you're more or less a great power, it just won't pay. The Non-Proliferation Treaty can be strengthened by having nuclear weapons states stop making their weapons better and continuing to cut significantly lower. And in that case, the great powers will be more in compliance, and that would encourage smaller powers to not even think about it.
And Graciela Gelmini asks, and I think this is referring to nuclear planning, are the same type of considerations done in all nuclear countries, or are there substantial differences in this regard?
Yeah, I would not assume that the nature of the targeting is identical. The British in World War II had no problem bombing cities, and I have had hints that they may still, with many fewer weapons, plan on using them very efficiently in cities, not to bomb the city, but to bomb political control, let's say, or communications. I asked a leading historian, military historian, atomic historian in England if she could find out anything about this. And she's had access to everything. She told me she could not. Maybe she meant she could not tell me about it, but this didn't fall within her need to know. So I haven't even been able to find out about the British, let alone anyone else. That's a project that would be great for others to take on, and some have.
And Morton Brussel asks two related questions. Is the military the problem, or is it elsewhere? And how does economics, the weapons industry, keep the madness going?
I would not say the military is the problem. That's not my sense of it. They don't want to have a nuclear war. It's not good for anyone's career. There's a joke that the Navy's weapons used to be less accurate when submarine launched. And the question was, how is it an Air Force officer's reaction different from a naval officer after the beginning of a nuclear war? And the answer is that the Air Force officer plans to go have lunch with his wife and kids, and the nuclear submariner knows it's the end of the world. What was the second part?
Well, it was about economics.
Industry, yeah.
Yeah.
I'm sure it plays in. I don't think it drives it. There was something called The Last Supper when Bill Perry was secretary, in which he called in the heads of the absolutely largest military contractors and said, you are going to shrink. Your business is going to shrink. That is my goal, or part of my goal, and you better do something about it. And so there were a lot of mergers. I'm sure at the congressional level, there's obviously pressure for this system or that system. The procurement is done in every state for that reason. But I don't think that economics drives it.
And Talia Weiss asks, what do you see as the similarities and differences between the psychological and institutional factors experienced by military nuclear war planners and those experienced by scientists working to develop dual-use technologies or technologies that raise moral questions in a different manner?
I would expect there to be a great similarity. I don't know if the socialization and the career paths are quite as narrow as in the military. I don't know if the oaths taken by the military of obedience, but also of doing right, I don't know that that is as widespread. But in general, if you break an overall goal down into the tasks that people must do, you can separate yourself from what the consequences will be because you're just doing your little part.
So I see two remaining questions in the Q&A, and those will be the last two questions. And I think those are more appropriately addressed to our other two speakers. So I'll ask Matt, that Peter Somsich asks, are fallout shelters now no longer needed? What has changed since the 1960s?
Well, what changed is we no longer have a national civil defense program. My grandfather was actually in charge of civil defense in his small town in Massachusetts in the 50s, late 50s, and he saved his civil defense instruction book and showed it to me, and it showed a 1 megaton nuclear detonation over Boston and the fallout heading towards central Massachusetts, and his job was to maintain the fallout shelter and to make sure people could go there. But what I do see are some of the same questions, some of the same issues coming up in the terrorist nuclear use set of issues. Primarily, shelter in place or evacuate. What's the safer choice? How extensively does the government monitor for radiation anomalies in the environment to try and detect a nuclear device? So I'll leave it at that.
Okay, and our last question from Graciela Gelmini, how many people would survive the initial explosions and fires? And how many of these people would survive the paucity of food? Alan?
First of all, about fallout shelters, you'd need many years worth of food and enough weapons to keep all your hungry neighbors out. I don't think it's really a plan for surviving, period. And the number of people that would survive the direct effects would be horrible. Tens of millions of people. It depends exactly what the targets are, but the people that would die from starvation are many, many more. People around the whole world, far removed from where bombs were dropped. That's why this is a problem for everybody in the world, not just the places that might be targeted. And it would depend on the amount of smoke and what the scenario is. But people talk about limited nuclear war, but once it starts, it's kind of hard to limit it. Communications breaks down, military people fire their weapons without somebody telling them to do. And the only nuclear war we ever had, the entire global nuclear arsenal was used.
Well, that is all the time we have for today. I'd like to thank our three speakers. I'd like to thank all of our attendees. I think we had as many as 80 attendees at one point. As I mentioned at the beginning, the goal of the coalition and the goal of this webinar is to raise awareness of the threats that nuclear weapons pose to civilization. I think all of our speakers have done that, and I hope it will motivate all of our attendees to support efforts to reduce those risks. Thanks to you all, and I hope to see you at a future webinar or coalition event.
Bye-bye.